Good morning, good afternoon, good evening, wherever you may be. It's another exciting adventures in ACE Academy 7th grade science from deep in the Brunner bunker in the quarantined Southeast United States. Here we go with another edition of Mr. Brumman's science class. I hope everybody has had a fantastic break. I know a bunch of you guys got your work done for your assessment for the last unit. I really appreciate you getting that taken care of. Those of you out there who didn't take the assessment know who you are. Please go back into the classroom settings, not settings, go into classroom and make sure you get that taken care of. I mean, it is an assessment. You guys know who you are. I'm going to start calling parents today to make sure they're aware of that have happened. All right, so we start a new unit today. As you can see on the screen here, it's 7.E.1.1, Earth Systems, and it says I right here can describe the contents of the Earth's atmosphere. That is our I can do statement for today. So the contents meaning, what it is made of. So we're going to investigate what the atmosphere is made of today. So first of all, what is an atmosphere? The atmosphere, as we go to, wander on down here, the atmosphere is the envelope of gas that surrounds a planet. So right here we have a picture. This is the picture of Earth. So as we see, the surface of the Earth down here. Oh, let me turn on my annotation feature. Here we go. So the surface of the Earth is down here. Oh, it's blue. Let's change up the color that actually contrasts. So the surface of the Earth is down here. So way down at the very bottom. There's a piece right there where we can see the ocean. But for the most part, you can barely see the surface of the Earth. As far as like actually covering. So, oh, I just turned it off. Fantastic. Can I move this bar? Oh, thank you. Okay, so the surface of the Earth is way down here. So obviously this is over the ocean. You can see deep blue down here. But as we come up further in the atmosphere, you can see clouds. Just normal clouds, and then the occasional thunderhead poking up right in here, right in here. Right there's a thunderhead poking up. That's a pretty good sized development storm. So, thunderheads where thunderstorms occur, stick way up higher into the atmosphere. The top of some of the biggest thunderstorms out in the Midwest, where you have all those crazy tornadoes and stuff, actually go up as high as 60,000 feet. So that's way out of the range of the normal weather chunk of our atmosphere. So you just got to kind of remember that piece of it. So yeah, the normal weather tops of even big thunderstorms here in the East Coast is about 30, 32, 35,000 feet. So I mean, but they can, like I said, can get up to 60,000 feet out there in the Midwest, where you have some of the more crazy, big tornadoes and stuff, and more crazy atmosphere weather systems. But other than that, so most of these things, right there's one sticking up. That's a pretty tall one. So I would say that's probably 30, 35,000 feet. As your gaze moves up this way, whoa, you're going to notice right here. Here's the curve of the surface of the Earth, and then everything above that is what we're seeing is the atmosphere. So the atmosphere, again, that's that envelope of gas that surrounds a planet. Why does it stay there? Gravity, because remember, gas molecules are actual mass, and the gravity pulls things down, so it pulls things that have mass down, giving them weight. So these air molecules, these gas molecules, are pulled down towards the surface of the Earth by gravity. So as your gaze moves up, you're going to notice the area where the layers start to have different colors. So right down here at the base, it's it's pure, kind of white. You can barely see through it. But as you move this way in it, the most basic layer, runs to about right there. And then above that, you get a layer that runs to about right there. And then the outer layer runs to about right there. Now, I mean, is that 3 layers of atmosphere? No, not really. There's more than that. But just in seeing it here, you have the most dense layer down here that's easily visible. Then you have this layer here, and then you have this layer here, and then out this way is, guess what? Guess what those things are? Stars. So that is what? Space. So so this kind of gives you the idea that the atmosphere kind of puts itself in the layers just almost automatically, just through the gravitational effects of the planet. Um, and what you can't see down here at the very base, I mean, if you could look right here, there's a layer, you know, you could almost see that, and then that, and that, that, and then it goes that, and then it goes that. So it's like 1, 2, 3, 4, 5. That's almost layers of actual atmosphere that you see. Um, but that's what that is. So those are the layers of the atmosphere, kind of in visibly laid out here on this in this picture of the surface of the Earth, taken obviously from space, probably the International Space Station or something along those lines. So most planets, well, I say most planets, yeah, actually most planets have some sort of atmosphere. Now, does the fact that they have an atmosphere mean people or anything can live there? Not necessarily. You wander on down. Let's just wander on down here. The paper will turn this off. Wander on down here in the paper. Oh, take. Okay. Oh, all right. So wander on down here. This picture right here. This is Mars, and so Mars is currently the one thing that all the people are talking about. Where Elon Musk says he's he sent that car there on a rocket. Get there in 10 or 15 years or something like that. But Mars is where we're seem to be intent on sending humans there in the next couple of years. Um, between Elon Musk and NASA, there's definitely a huge push of getting people to the Mars, or as they call it, the red planet. You can see in the picture. Yeah, guess what? It does look actually fairly kind of like red. But you can see here in the advanced portion of top portion of this. Once again, there's the surface. Well, color choice again has failed me, because now we have a red planet. We need a blue marker to really have it show up. So there's the surface of the Earth planet, and then there's the top of the atmosphere. You really can't. Yeah, you definitely see stars right there. So that's pretty much it. So does it have as much atmosphere as the Earth does? No, not really. I mean, again, and remember, Mars is actually smaller than the Earth by a decent amount. So gravity is less there, so it is captured and kept less gas there, but it does have somewhat of an atmosphere, and it does contain a little bit of oxygen. So it is not totally, um, you know, poisonous to us to go out and breathe it. There's just not enough oxygen there to support life, as we know it here on Earth. But that's why we want to go there, is because it does have enough of an atmosphere with enough of the right things in it that it's not going to kill you if you open a window and let all your inside air out. As opposed to someplace like Venus. Oh, let's jump over here, and I should have prepared this, but I was actually looking at this earlier. Um, Deliver happiness. Venus. Now, Venus is a planet that's actually about the same size as Earth, but there's a good picture of it right there. But unfortunately, Venus's atmosphere is mostly carbon dioxide. And despite these pictures down here, it's like, no, that's not what it looks like, and no, that's not what it looks like either. But carbon dioxide just happens to be molecularly heavier than nitrogen and oxygen. And so thereby the gravity of Venus, being a similar size to the Earth, pulls down on those molecules. So at the surface of Venus, the air pressure is about 90 times what it is here on Earth. So it would feel like you were at the bottom of, I don't know, a couple hundred feet of water, just trying to stand on the surface. But also because 94% of the atmosphere of Venus is carbon dioxide, it also is incredibly hot, like fire all the time hot. So it is a place that, that's why we talk about going to Mars for terraforming and putting people over there to live, versus going to Venus, which, hey, it's a planet close by, similar size, similar gravity, but the atmosphere is nothing we could deal with. Mars, on the other hand, we can actually deal with the lighter gravity, and we can deal with an atmosphere there that we could act it is not actually poisonous and weighs so much that we physically would just be laying flat on the ground dying. So that's what different atmospheres do. So then you get to the point where you actually have no atmosphere. So this little planetoid little thing right here is called Makemake, and yes, its actual name is Makemake. It's named after a Polynesian god. It is one of the they call it an exoplanet, they call it a near planet, they call it a all kinds of different stuff, but it's out there beyond Pluto, which goes from being a planet to not being a planet to being planetoid to being um, another thing that orbits the Earth. So Makemake is about 4 billion miles from the sun. So in this picture, this is not an actual picture. This is an artist's rendition, but you can see there's the sun. It's just a bright star in the sky. It's not actually providing a whole lot of light. They've really illuminated the surface of the planet a lot brighter than it would be. But you can see right here, there is no atmosphere whatsoever in this illustration of this of Makemake. Now, it is not the last thing in our solar system because you have Makemake, which is on the inside of what they call the Kuiper belt. Kuiper spelled Kuiper, just for name sakes for astronautics later down the road, the Kuiper belt. And then you have the belt of all this material sitting out there, a bunch of asteroids and comets and stuff like that. And then on the other side of the Kuiper belt is the largest non-planet planet that orbits the Earth, called Eros. Not Eros. Well, now I see. I have to pause for a second here while I refresh my memory. But on the other side of the Kuiper belt is the largest exoplanet. So exoplanet. Why I suddenly can't remember the name of that thing. It's just driving me nuts. But we'll figure it out here in a second, but we'll continue. Kepler. Kuip belt. But anyway, so Kuiper Belt is just a mass of debris, effectively that has been around since the formation of the solar system, way out past Pluto, and out there is and even further out is what they call the Oort cloud, OORT, which is where anyway, that's where all the comets hang out. The Kuiper Belt's a bunch of similar to the asteroid belt. Oh wow! And there's another one called Arrokoth, Arrokoth, which lives out there. But I'm losing my mind because I cannot think of the other name, and it's driving me crazy at this point. And you know how it is when something you're like, oh yeah, I know what this is. But then it's like, All right, I'm just going to forget about that. So anyway, so there's other things out there, but all these things out there in the Cooper Belt, such as Makemake and Aragoth, Aragoth, are they don't have atmosphere. They're just little bitty planetoids, as you will, way far out there. So as we talk about continuing to talk about the atmosphere, so in order for advanced life to occur, you need to have an atmosphere. Earth's atmosphere is composed of gases, and remember, so I can describe the contents of the Earth's atmosphere. So we went over what an atmosphere was, and now we're actually getting to the contents of it. So this is the piece that you really do need to know. So in order for advanced life to occur, you need to have an atmosphere. Earth's atmosphere is composed of gases. Nitrogen makes up the largest percentage, about 78%. Oxygen is second at 21%. Thank goodness, because we do need oxygen to live. Argon's third with 0.93%. So now we've gone from 78% to 21%, and now the next chunk of it is 0.93. So it's literally less than a percent. So we want to massive chunk to decent sized chunk to bitty slice of the atmosphere. So again, so that for all effects and purposes, the atmosphere basically consists of nitrogen and oxygen, and with a bunch of smaller things. So argon's third with 0.93%. Carbon dioxide's fourth at 0.04%. They keep down, 0.04% carbon dioxide. That's a very small number, right? And then the rest of the atmosphere are gases, trace amounts of neon, helium, methane, and krypton. So at right now, we have what things? We have basically 8 things: nitrogen, oxygen, argon, carbon dioxide. There's 4. And then you got neon, helium, methane, krypton. There's 8 gases. So if somebody asked you, what does the atmosphere made of? You should be able to pop off nitrogen, oxygen, argon, carbon dioxide, neon, helium, methane, krypton. And then the last component of the atmosphere varies greatly from place to place, is water vapor. Water vapor is the gaseous form of water, H2O. But depending on where you are, water vapor goes from 0% to 3%. So if you're in the desert, there's no water vapor running around the atmosphere in the desert. That's why it's a desert. There's pretty much 0 water vapor there, except for that one time in 20 years that actually you get a little bit of rain in the desert, which does happen, but that's a rarity. For the most part, you have 0%. So water vapor can't really be considered a gaseous portion of the atmosphere because it varies so greatly from place to place on Earth. But as something we need to know, you need to know the atmosphere normally has water vapor in it, and especially here in North Carolina. We always have water vapor here because it rains on a regular basis. As if you look out the window today, you can tell. So here in North Carolina, we do have water vapor on a regular basis. So 8 gases plus water vapor, there's your atmosphere. So now it goes on down over here. So if you look right here, it says the mist. Well, no, it's not the mist. It's the mix of gases is pretty consistent up to about 30,000 feet. Remember I told you, guess what? Thunderstorms hit, 30, 33, 35,000 feet. It's the top of most thunderstorms here, especially the East Coast. But they can get a lot higher than that. So yeah, so when they stick up way higher than this, they're up into a different piece of the atmosphere that has a, less, and the mix kind of changes. But for the places where weather and things normally occur, especially for us as humans that we live, the gases are pretty consistent to the point where you don't really have to they don't change scientifically enough to talk about. So the gases of the atmosphere are what allow life to exist on Earth. They're constantly used and renewed by the life processes on Earth: respiration, photosynthesis, evaporation, condensation, and weathering, and the breakdown of rock and the decay of organic matter. All of these contribute to the cycling of matter that makes up the atmosphere. So this huge monolithic chunk of nitrogen, 78% right here, it's not like that nitrogen just sits there and does nothing and just stays at 78%, and those molecules of nitrogen don't do anything. It's just going to bounce around and happen. No. The nitrogen, we studied the nitrogen cycle a little bit. So nitrogen does cycle in and out of the atmosphere into different things on the Earth. Plants need nitrogen to live. There's a process called nitrogen fixation, where they take that atmospheric nitrogen, gets down in the soil, and they fix it into things that they need. fertilizers that you put on the ground a lot of times contain nitrogen in a fixed, solid form. So plants do need nitrogen. So we got to get that nitrogen doesn't just, it's not a monolith, it doesn't stay up there. And so of course, obviously oxygen, we're using oxygen on a regular basis. We breathe it in, we change, combine it with carbon and then breathe it out as carbon dioxide. So oxygen is constantly being cycled in and out. Now argon, right here at 90.93%, and then neon, helium, and krypton. Argon, neon, helium, and krypton. Those four gases are what we call Nobel gases. They don't actually react with anything else. Now, methane is, all right, how can we say this politely? Methane is basically, a gas that is a CH4. It's a hydrocarbon. It comes typically you'll get methane out of when you drill for oil. You'll run into gas like methane. Highly flammable. Smells horrible. So that that little trace amount of methane in the atmosphere comes from the decay of organic matter, effectively. So I mean, what is oil but squashed plants kept under pressure down underneath the earth. So that methane is a byproduct of the decay of organic matter right there. So what is the contents, what are the contents of the atmosphere? Nitrogen, oxygen, argon, carbon dioxide, neon, helium, methane, krypton, and depending on where you are, varying amounts of water vapor. You need to be able to answer that question. Anything else for today? Hey, great. Just remember for today's assignment is simply just build the 7.E.1.1 word list, and we'll catch you guys on the flip side tomorrow. Hope to see some of you guys at the Zoom today. Have a great one. We'll see you later.